All right, so we were talking about intermittent organs at the very end of class with the goal of thinking about, now that we're talking about chondrichthyes, right? Our goal is to think about within the class chondrichthyes, how can our subclasses, elasmobranchii versus holocephali, right? Sharks, skates, and rays that we normally think about as cartilaginous fishes, and the weird cartilaginous fishes, how can these be separated? So the first thing we started talking about was reproduction. And so we needed to do a little review. Then we talked a little bit, feel that coming, about the intermittent organ, right? And so we remembered at the very end of class that this is something we've seen in our chondrichthyes, specifically in that dogfish before. So this is an organ that exists to help or aid in making internal fertilization more effective or more efficient. So this is something we see in elasmobranchii. Right, so this is one of the two subclasses. Under our chondrichthyes, right? So everybody in this subclass, right, is going to be doing internal fertilization. And this is one way we can start to see those differences. And we're being successful at internal fertilization because we do have that intermittent organ, which is also pretty uncommon in any kind of fish in general, let alone some kind of chondrichthyes. Right, sort of if we imagine fish, right, we tend to imagine some sort of external fertilization. Okay, but remember here, and we know they largely do internal, right, thanks to this clasper system, right, which was one of the first ones we encountered, right? This both holds on to the female, okay, hence its name, right, we're clasping. Okay, and they can use them, right, to literally act as like a slide, right, or a tube, so to speak, to really help funnel their gametes into the female. So we're getting really much higher efficiency of successive gametic transfer. Okay, this feels pretty good. It feels familiar, okay? And this is something we've gotten to have some hands-on experience with. Oh my gosh, I hate that it has its own like Chrome pop-up. It just gets under my nerves. So let's go ahead and think about internal fertilization as a good reminder. So we haven't done a Menti for a while as a group either, and I think it'll be nice, particularly given the chaos of last week. So let's all go to menti.com. Yes, subclass, very exciting. Okay, or if you've got the app, right, living your best life, okay? And we're going to use our code, right, 38, 45, 27, 8. Okay, and you have a series of pictures that we're going to be looking at, some of which we've seen before. Woo! And we want to think about, given our list and our original definition of internal fertilization, which we haven't talked about discretely, right, since our vocab lecture. Okay, but what kinds of animals perform internal fertilization? Man. Yeah. Guess we are a little short-handed today, aren't we? Okay. So let's look at our animals, which are looking a little shrunken and dull today, but that's okay. So let's just start and move left to right. So option 1, which was a popular option, what kind of animal is our option 1? It's a shark. Okay, given that this is our unit, right? This guy doing internal fertilization. Okay. What kind of intermittent organ does our shark have? We're going to have some kind of class first, right? Good. I am writing bigger than usual. Okay, how about our pink one? What's that? Some kind of mouse. It's a little better. Okay, so if a mouse is doing internal fertilization, what kind of intermittent organ is our mouse using? Mouse is a mammal. Pretty standard fare kind of business. Okay, how about our red one? What's that? Dolphin, good. Okay, what's our dolphin going to use as an intermittent organ? Also a penis, right? Dolphin is also a mammal. So we're going to use standard fare mammal things. Okay, those weren't too bad. Those were our most popular options, right? So we've seen these before. We're doing a good job of recognizing them. Let's talk about our yellow one. This one's gotten a little shine. What's our yellow guy? Some kind of salamander. Right on top, not necessarily to mean anything besides I'm running out of space. So these are all correct, right? All right, so we seemed on the fence / not super popular choice. Say again? So some amphibians do external fertilization.
See, I thought that was the one that sat on it, and then that's what I was thinking.
So many amphibians perform external fertilization, right? We can picture frogs, for example, just dropping a ton of their eggs, and then the male frog following it up, right? Our classic lay and spray. But salamanders did do internal fertilization, right? So remember, salamanders, the entire group, right? So our order, Chordata, okay, used a very unusual system. Okay, so their intermittent organ was the spermatophores. Remember, that was the present or the package, right, where the males lay, right, that pretty little box of sperm, right, gifting it to the female, right, who then can sit on it and accept it. Right, so it's still internal fertilization, right? So remember, that's asking the question, where do the egg and the sperm meet? Right, and with our caudata, our salamanders, right, remember, okay, even though it's weird, okay, although vaguely romantic, okay, it's still meeting inside the female. Okay, what about the goose thing? And we seemed 50-50 here.
I chose that one, but now I'm thinking. Yeah, I think that I chose it, but I don't think it's right. I don't think they lay eggs in that.
Okay, so birds do lay eggs, right? We know this. Okay. What do their eggs look like when they're laid? They're hard. Okay, so this is really key when we think about this. So if I, the lady goose, okay, an angry lady goose, I've never seen a nice goose. Right, so I'm an angry lady goose, and I've laid my eggs, and they're already hard, right? I'll handle some kind of bird egg at some point. If I'm a boy goose and I come around then, okay, can I fertilize an egg that has a shell on it? No, right? I can do whatever to these eggs. If there's already a shell on it, nothing's going to happen to them, right? That's kind of one of the key features of shells, is it protects anything from happening to them, including, in this case, fertilization, once they've been laid. So when does a bird egg need to be fertilized? Beforehand, right? Or internally, when they're still soft, or before we put on that hard protective casing. All right, so how would I, as a bird then, this one's probably one of the hardest ones to picture. We've only mentioned this in passing. Does anyone remember how birds manage this? Cloacal swelling, good. Unless I'm a duck, then I have a corkscrew penis. Hmm? The corkscrew one. Now that's a lock and key system. All right. But this is normal. This is much more standard. Which is why I did not choose duck. That's all something you can Google when you leave today and have that for the rest of your life. Okay. Option 6. What's that?
I thought it looked like a shark, so I thought it was a fish.
Some sort of, yeah, so if this is shark, right? This is something large and mean, but maybe not shark, right? So if we chose shark, should that say internal? Okay, if we chose not shark, but regular fish.
External.
Fish should be external, right? Most of the time. Okay, some exclusions certainly apply. But generally speaking, most of our fish are external. Right, they lay those soft little jelly eggs, okay, either in nests or in the air, water, a very exciting little fish. Okay, and the males can follow that out, and because those eggs have soft exteriors, right, then when the males follow that up, right, and spray their gametes on them, that sperm is able to penetrate that soft exterior and successfully fertilize those eggs. Okay, does everybody see how we worked through this? Okay, so this is certainly helpful for our sharks, but it makes a good review to kind of think about this term again. And we'll be reinforcing this, of course, as we go through all of these classes. Okay. So I want to think about then for a second, because we're going to talk about internal and external fertilization a lot. And we've talked in lab about it a little bit as we think about, well, we've had both sharks and osteichthyes there, right? And we know sharks tend to do internal fertilization. Osteichthyes, for example, tend to do external fertilization. So we can think of off the bat two classes that are often taking different approaches. Okay, so why? Okay, as we found so far, as we've thought about our vocab and the different traits that we've seen, right, we know that these things are not very random, right? They're giving organisms, if we think about eyes, for example, right? Each thing has a different benefit for the space that they're in and then disadvantage as they move around, right? There's no such thing as perfection. So if I think about, for example, internal fertilization, and what's one benefit? Perhaps to the mother, perhaps to the father, perhaps to the offspring. Say again for me. Mm-hmm. And the same thing for a disadvantage. Okay, it doesn't have to be the same. Okay, alternatively, okay, or it could be the same. All right, also offspring for both or mom for both. Okay, I don't care. But for one of those three individuals, and then do the same thing for external fertilization. Okay, we want a benefit and a disadvantage to one of those three individuals, right, involved with the process. Right, because it can't be a benefit to everybody, or it would just be the way everybody did it all the time, right? And we already thought of one problem with internal or external fertilization, right? When we were talking about those birds' eggs. Right, so if I'm on land, okay, I really can't lay my eggs and fertilize them afterwards, right? Because my eggs have to have those hard coatings on them. You can't fertilize an egg that has hard coatings. And there's way more than that, so don't feel the need to necessarily put that down. But these are the kinds of things we want to think about. Right? What limits me and makes it awesome all at the same time? Okay, let's start by just thinking about the internal fertilization version. Okay, what are some benefits to doing internal fertilization? Why would I, as a class, right, be choosing this version of fertilization? Okay, that's a big one, right? Offspring protection. Well, I couldn't spell for a second there. My apologies. Okay, most of the time with internal fertilization, okay, there's some kind of offspring protection involved. Usually mom is staying pregnant a little bit longer, or dad, right, in the case of seahorses. But whatever the case is, right, any amount of time that they're staying with mom, they're getting more nutrients, right, so longer growth time in situ, or inside, okay, as well as just more time that they can't easily be picked off by a predator because mom or dad is just literally there as the bigger, badder option. Little plus symbol. Okay, what else? Good or bad?
Bad, the amount of time that it's naturally produced, maybe it's less offspring.
Yeah, so there's cost here. Okay, if I'm investing the energy in things like offspring protection, okay, or housing them in my body, there's a cost to that. My body only has so much space as mama shark, right? Plus, dad or I, right, have to spend the energy actually caring for them. Okay, so the number of offspring has to be less. Okay, they may be bigger, okay, and more likely to survive in the end, right? Okay, but I'm unlikely to put out 200 million at once. Okay, sort of when you think about opening up the insides of your fishes, you could see many, many eggs that hadn't been laid, but we ran into our pregnant dogfish, we didn't see, right, 200,000 eggs. We saw, 6 egg yolks. Okay, so that really shows us that cost balance. Okay, there were much larger egg yolks, right, way, 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 way bigger, okay, but there were way, 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 way less. Okay, what else? What if I'm dad? What might be the benefit from internal fertilization if I'm dad? Do I know those babies are mine? Okay, that's actually a big deal, right? So for both dad and mom, okay, but really from dad's perspective in this case, right, I have known paternity. So I've put investment in, all right, perhaps I've done some behavioral reproductive isolation, I've put in some breeding, maybe I built a nest, okay, I've attracted a lady, okay, but in this case with internal fertilization, we had some one-on-one courtship time. Okay, so I know that the offspring that come out of this at least are very highly likely mine, depending on her fidelity, right? So any amount of time I'm putting in after the fact or before the fact, right, building a good nest, protecting the female, maybe I'm protecting the babies afterwards, okay, that's investment directly into my genetic lineage, right? I know, or I'm very likely sure, those are my children. What about from mom's perspective?
I put a disadvantage in that things for hormonal.
Good, right? So from mom's perspective, right, this is great. I get to pick the father of my children, blah, 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 okay? But there is a big cost to mom here, okay? Because she's doing more of the protection largely here, right? Because she has to carry around the offspring for a larger portion of time. Okay, and that carry is very much more expensive on her, right? It's hard to be pregnant, okay? Particularly the way we're thinking about it now, because we're underwater, right? So we are going to, by definition, break that fusiform body shape, okay? And that's going to cost her. It's going to make her slow or slower, and it's going to make her very attractive as a meal, right? Because she's going to be fat and delicious and nutritiously good for anybody that's a predator to her. And because she's not fusiform anymore, she's going to be significantly easier to catch. Okay, so this is a high cost time period for our lady fish. And this is commonly why you see couples stay together during this period, because it's easier for the male to leave and go do stuff than it is for the female to do so. A good benefit for the partner. You have to pick a good daddy in some cases. It's literally life or death. Okay, so these are some of the major ones that we want to be thinking about. As we think about, right, major benefits, offspring protection, known paternity. Super.
I was just curious about what would a benefit be for the mom in the situation for internal fertilization. We talked about the disadvantage of that mom is more at risk for pregnancy. What would be the advantage to mom for internal fertilization?
Right. So the question is, what is the benefit directly for mom, right? And so not necessarily anything specific. And in this case, it's going to be a delicate balance of mom's cost, right, and being able to choose a good male partner. Right. So the biggest benefit overall is this offspring component, right? Being able to have the healthiest children that are more likely to survive. Right. There are some situations like the octopus, right, or several organisms in which both, right, the female, for example, octopus, when she lays her eggs, will protect them until she dies, right? Or several organisms we can think of, like fishes, salmon, and lamprey, right, that go to the new safe breeding sites, breed, lay their eggs, and then they die there. Okay, so the cost of breeding sometimes is so high, right, that either the protection of the nest or the eggs or the act of breeding itself will kill you. Okay, so costs are high. Okay, so let's then think about the opposite. I don't have a clean slide in between, so you guys are just going to have to laugh at the difficulty of internal fertilization, I guess. So let's think of the opposite and do the same for external. So what are the benefits and disadvantages of external fertilization?
The mother's not weakened. The mother isn't weakened a lot of the time.
All right, so that's a Benny, right? So external fertilization is much easier on mom. Right? She still has to get a little bit big to carry the eggs around before she lays them, but this is a much shorter time period. Okay, often, for example, with some fishes, it's just a matter of days. Right? You can produce them up, particularly as a mature female, quite quickly.
environmental hazards. Like if water comes through the nest and kills everything, or drowns the dad.
Maria is not making a Disney movie over here.
No.
Right. So she is correct, however, right? Because the females are able to basically make a bunch of eggs all at the last minute, okay, we're able to produce, or at least fertilize, a much larger number of offspring. Okay, but hey, the downside to that is there's no expectation when you lay 100,000 eggs, okay, that next year 100,000 babies are going to come back alive, well, and 1 year old. Okay, that's just the facts of life. So you know that a very small proportion, 0.5%, 1%, 3% if it's a very good year, right, of those eggs are going to come back as 1 year old babies. So the survival rate's very small, right? Because we're just not investing energy into taking care of them, right? It's just sort of like, yep, you got it. See you next year.
Are the animals that like lay their babies and then like have nothing else to do with them, like they just leave? Yeah. Do they recognize them as their children if they were to run into them? Like, is that possible?
Not necessarily. So, okay, so the question is, for organisms that lay mass amounts of offspring, okay, do they recognize them as their own offspring? And so I guess it depends on what you mean by that, right? So inbreeding in populations is naturally very low, right, across all animals. You only see any kind of inbreeding, right, in populations that are like endangered, right? So there's only less than 20, so the likelihood they're going to sleep with your own daughter is pretty high because it's really all there is, right? So you see that in things like lions, etc., because there's like only 10 of them. So yes, right, because it's unattractive and unlikely that you would sleep with your own children. That being said, okay, if, for example, I'm a fish, right, I've produced many, many offspring, okay, I will not necessarily recognize them as my own children, and it would not stop me from, say, eating them. Right? They're smaller than me. I'm a big fish. Anything of that size class is food to me. I will eat my children. Right? So several species do that. Minutes after birth, it's a whole thing.
What's the point? They're all bad.
Well, so two things, right? One, it would be unlikely, even with a voraciously large and hungry mother, that she would be able to eat all of her offspring again. And it does counterbalance a little bit, right? Because mom may be in poor shape, which would be why she would do this. Mom would be in poor shape after giving birth, right? And so whatever balance she gets back after consuming her own children would be more likely to increase her life, and the likelihood that all of those babies would survive would be quite small anyway.
Sorry, Tim, you're going to die anyways.
You're going to die anyway. You might as well keep me from dying because I'm more likely to live. Right? So it takes a whole meaning to you literally owe me your life, I gave birth to you, which I think we've all heard at least once, right? At least our moms didn't mean that. Okay. What else might be a disadvantage as we're finishing this up here? Well, we got way too chatty about killing babies. At least Dr. Dill didn't walk in on that one, right?
You don't know who the dad is, so you can have an unfit dad, and then all your babies could die for a different reason.
Good. And so from dad's perspective, or maybe from mom's perspective, right, paternity is more problematic, right? When a female goes to lay her eggs, right, often she's chosen a mate, but because she's laid her eggs in a space, right, oftentimes many males rush over to this space in a mad dash for fertilization. Sometimes it's the male that she wants, okay? Sometimes it's not. And from the male's perspective, man, that sucks, right? To put all that time in building a nest, wooing a lady, and then have some quick little speedy dude come in and get all the glory. Okay, so paternity is much more complicated and difficult than external fertilization, right? Because it's literally all out in the open. Okay, there's much less of a guarantee. Okay, I did get the socrative up. Let's see if we can. There really isn't a good